Welcome on this wonderful day to my pick of the week of IT-related topics. In these videos you will find knowledge and noteworthy things for developers and IT architects in regular intervals. It's about new discoveries, it's also about hype topics, as well as oldies but goldies. I've been fascinated by these topics for more than 30 years up to now, and I really hope I can show you some things which might be interesting for you as well. I wish you all a lot of fun in the next few minutes. So let's go. Yes, hi again. After a short winter break, I'm back again. In those days, I just bought a Pixoo 64 DVOM, and this is of course not a commercial video on that thing, but I think it's quite interesting to see what we can do with that kind of gadget. So as you can see here, of course you can display a lot of 64 by 64 images. Animated GIFs are also possible, and this is quite neat. You can display the time and so on. The interesting thing is that there are some applications installable. For example, you can just see the results from the Olympic Games. And the question is, okay, how can we achieve these kinds of applications when buying such a device? And so the question came up to me, how can I use the Pixoo 64 in the right way? Which of course means for me, how can we use the Pixoo 64 the more nerdy way? The normal way to use your Pixoo 64 is by an app, which you can just download for iOS or Android. And there are a lot of predefined images or images from a user gallery. And with a simple click on that image, it's just uploaded to the device and you can just see the results directly. Of course, you can just add your own images by using the app. So you can just paint inside the app, or you can just create some animated GIFs inside the app, store that on the device, and then see the results directly also on your Pixoo. So this is quite neat, but the question is, how can we add some more logic, or can we just use, for example, your local PC or other devices instead of your Android device or your iOS device to produce such devices? So the question is, how can we control this device from your PC? So I started to do some research, and okay, after some minutes, I just found out that there is an official website from DVOM where is exactly described on how you can use the device in a programmatic way. And this is by just doing some, they call it REST endpoints, so just doing some HTTP post requests. And there's a special website, which I also will link down below in the description of the video. And on this website, you can just find a lot of endpoints which can just be called. The most interesting ones can be found under animation functions. So this is the ones I think are the most interesting ones when it comes to the point that you want to display anything on your DVOM. If you just want to use these functions, I would say, of course this can be done by a program like Postman or whatsoever. But if you want to do it in a more programmatic way, you just need something like a library or something else, which is a good abstraction for these HTTP requests. And there is a great work already done by Ron Tellman, who wrote a library which makes it much more easy not only to abstract from these HTTP requests, but also his idea was just to create images in a programmatic way and then bring this image up to the DVOM 64 device. So I will just also bring up the link in the video description below. With this, it is very easy to write some Python programs, store them on your PC or your MacBook or your notebook or whatsoever, and just run it, and then you can just do some programmatic applications which can be seen on your Pixoo 64 device. The question is, okay, but what if you don't want to run your notebook all the time or your PC all the time? And I had another question, and this was, okay, I think it's quite interesting to use this one as a display, for example, temperature or humidity. And so the question which I had after a few moments was, can I just use my ESP32 board for that? So as you can see on the left side, this is. And the answer is, of course, we can. So I wrote a small library which does more or less the same than the Python library, but just for the ESP32. And I wired some stuff together. And as a result, I had a small setup with a battery, the sensor, the ESP dev board, as you can see here, which then transmits it to the Pixoo 64. And on the Pixoo 64, you can just see on the top left the temperature, humidity, the time, and some news in German. And now I want to show how you can achieve that. Yeah, the best starting point is the Github Repository, which I will link below. This is the code which I wrote in the first version. I have some documentation on the available functions. There is one class, the DVOM 64 communicator class, which I wrote, and the other stuff is the RGB helper library. And how you can use it is the following way, the most easiest one, I think. So I use the platform IO to build up projects for the ESP32. I switched to the platform IO instead of the Arduino Studio because I find it much more useful and much more easier to use. So yeah, how do you use this library in your own project? So first of all, you just start a new project here. Let's say DVOM 64. You need to select the board. In my case, it's the, I'll take ESP42 fella, so this one. Might be the correct one, and the framework is Arduino, so that's everything is just fine, and you can just start, and it creates the folder, and here we are. So this one here on top is my project, which as a result shows this news project, etc. And I will steal some code of that, so with that we can just go through here very fast. So how to import and how to use the library itself. So the library itself goes here in this lib folder. It is described here it's described here in detail. And the most easiest way is you just go to this GitHub area, and you can just, for example, download the zip file here. And yeah, then you can just open the zip file. Then you need to unzip the file here. And then you can just copy these files here inside this library folder here. Does it, okay, that works just like that. Then you can just use the library inside your main CPP file. So that is quite easy and more convenient than in the Arduino Studio, on the Arduino Ide, I think it's called. But everything else looks more or less similar. So we have the setup and the loop function, which should be familiar to you if you used the Arduino Ide to code something. And the setup file, of course, the setup functions here is called at the beginning, just it's as an initializer. And the loop function afterwards loops after the setup. Okay, I will just copy some code over from my old project and we'll delete the stuff we do not need. That should go very fast. So first of all, the includes. Okay, we see here the Arduino is doubled. This is stuff we do not need because this is for the temperature sensor and this is for the news, the XML parser I'm using there. But the rest we do need. So the HTTP client and the Wi-Fi client and the library here itself we also do need. So at the very beginning, there's one thing which I will change in the near future, but what you need to do by hand currently, you need to go to the devom library. And as you can see here in the C++ file here, is this devom address. This is the address of your devom in your local network. So in your wireless LAN network. In my case, it's the private IP address .115, I assume. This, of course, will be different in your network. And you have to change the address here in the CPP file. Yes, and then we are good to go. And I switch over to my first example. We'll speed it up a little bit. So we do not need all that stuff here because that's for the sensors, etc. What you need, of course, is the SSID and the password from your network. And we will need this RGB my screen stuff. I copy that over. So this is blurred out here in that case, but you need to type in the appropriate values for your network, so your SSID and your password. So this one here is the first which is necessary just for using the library itself. I will come back to that later on. But first of all, in the setup, we need to connect to the web network and we need to set up the serial interface for debugging purposes. I just copy all the stuff here and then I delete all the stuff we do not need. So a small delay at the beginning, never a bad idea. Serial I will set now to 9.6 because that's the default and I don't want to change the config files now for a while. And then we have here deep sleep stuff. I just delete that because we do not need that. But after writing down hello Arduino, we are connecting to the Wi-Fi. This is what we do need. The XML parser is not needed, but the Wi-Fi begin is needed. And then this is prints out some dots until we are connected. And if we are connected, we are good to go. And I will come to this my screen URGB just in a second. To explain that now is the helper library itself, or the idea behind is the following. Instead of pushing a finally created picture directly to the Pixoo 64, the idea which I took directly from the Python library is that you create the picture in memory in the device and print all the stuff on that what you like to see and push then this picture to the Pixoo 64. So this is the idea behind, and therefore there are a lot of helper functions just to create this RGB image and to manipulate it. And therefore there are some functions available which we will use now to do the following. We will print a totally green picture. So we fill it up with green and then we will print out a rectangle on that. And and bring up some text on the device. So this is what we want to achieve. And this goes now to this loop here. I just copy the loop stuff again, so you don't need to follow. I just copy some of the stuff here, which makes it a little bit faster, and I do not need to type all the stuff. So Go is nice. Okay, temperature stuff we do not need. We don't have any sensors connected currently here. There's no current temperature. This is also my main system. But this is now the moment when we check again the Wi-Fi connection. If it is connected, the following happens. We create now a DVOM client from this class we included here. This is this DVOM stuff. And this client then makes the connection to the DVOM device and gives us some functions just to transmit the images or the text files directly to the DVOM 64. Yes, first of all, what did we say? We just want to fill the screen absolutely with green color. So as this is RGB values here, we say red is 0, green is 2.5, and blue is 0. This should give us a green screen. And afterwards, we are just plotting a rectangle here. And this rectangle then, I want to show it. Let's do it that way, that you have you see we have filled circles, we have filled rectangles. We just plot a rectangle here. What is quite nice about this platform IO stuff is that it gives more information while typing. So we can just see here now the function and the information here on top. So let's say we printed from x10 width, let's say 20, this one 5, and again 20, for example. Let's do like 40, maybe it's a good idea. And then we have again these RGB values, and we want to say that it's a blue one, so it's 0, 0, 255, and that should be it. Afterwards, I would like to print some text on that. So again, we have a function to do so. Let's copy this one here because it's much more easy just to I take this one again here. Oh, sorry. This we will need later on for the communication to the DVOM client. And we can use now the function for the text method. We can just go to the description here, for example, and have then the possibility to display some small text, or to display some. We take simply this send text method from the DVOM communicator class to do so. So switch over. So we have the screen here, and we have the DVOM client below. And as I said before, this one is responsible for the connection and for sending the information to the Pixoo 64. So first of all, we do a reset pic ID. I will just explain that in a second, and then we do this send RGB stuff. Afterwards, we do the following: just writing the text to the device. So we could again do this DVOM client and say send text. And the send text method again has an X value, let's say 5, 25, we say it's on 40. The string text, as always, let's say hello world. And a text ID and a color for that. So this is now in hex. We can enter something like 32, I don't know, 65A0. I have no clue of what that brings. So maybe I just take this from another example from me. So maybe this is a nicer color. I don't know. So, and that's not what I wanted to do. Sorry. This is all uncensored, live and in color. And now we have the font size itself. So we keep the default. So the font size is 3. Okay. This ID here, you have for when you display some text on the Devo device, you have the possibility to address them with certain IDs. That gives you the possibility, for example, to overwrite some text with new text, or you have the possibility just to delete text without any redrawing of the image itself, which is behind. You will see that just here in a second. All right, so this should be it. And then we do some delay, of course, because, well, let's say we wait here for 10 seconds, 10,000 milliseconds. And that should be it. Everything else is handled by the Devo client itself. So if we have this Devo client here, of course it deletes here the structure of this object, deletes some stuff, and then it's recreated again. Yeah, I think this is good to go. We will connect now the ESP development board, and after that we are just pressing the button here. I hope I've not that many mistakes. That looks quite okay. Okay, and now we see we are connecting and it's uploading. Quite good. So this small program is now uploaded to the ESP board. Yes, and now it's connected, and we can just use the serial monitor here just to connect, and then we should see, yeah, exactly. Hello Arduino, connecting to Wi-Fi, connected. And then we got the response to 100, which means, okay, we send it over to the device, and I bring in the image now, and you can now see that this is exactly what we wanted to see. So we have our screen in green, we have our blue rectangle on top, and we have the text on below, which says "Hello World." Okay, yeah, feel free to write your own little programs like that. I think that gives us a lot of possibilities to write some interesting stuff using our ESP devices or other Arduino-like devices. Yes, this is something different from what I did in the past few months before, but that was quite a nice interruption also for me. Yeah, have a nice day, have a nice weekend, and yeah, see you soon. I hope this was as much fun as it was for me. Okay, goodbye, have a nice day.